This time on Battle Factory, a sharp-looking weapon that's been a cut above since World War II. When you need to get 250 tons in the air, it's the only way to fly. Aiming for an enemy that's 2 kilometers away. And a mini-bomb that fights fire with fire. Battle Factory steps beyond the front lines into top-secret factories where combat gear is built for battle. When pounded with 100 tons of force, this sheet of steel will produce a blade that's honed by old-world craft and cutting-edge technology, and make an iconic knife that's as versatile as it is lethal. The K-Bar fighting and utility knife first saw action in 1942, when it was issued to the U.S. Marine Corps during World War II. Originally intended for hand-to-hand combat and basic needs, soldiers soon found that they were using the knife to defuse landmines, dig foxholes, as bayonets on rifles, and to open ammunition containers. For 70 years, it's been the favorite combat and utility weapon for service men and women. The knife is made up of a leather-crafted handle and a razor-sharp blade of tempered steel. The first step in making the knife is to take a sheet of steel called chrome vanadium and coat it with oil so it won't rust. Then, the 100-ton press punches out the blade. This kind of metal, used exclusively by K-Bar, is flexible and easy to sharpen. The added chrome makes it tough. The next step is stamping. Both the logo and the signature groove are stamped into the knife. This channel is called a blood groove, designed to make it easier to pull the knife from its target. Once they've been stamped, the blades move through a flat grinder. The blade is tapered towards the tip, creating a double edge, which gives the knife its signature look. The handle of the K-Bar knife is made up of leather washers. The washers are stacked tight onto the blade handle with a compressor. Then, all the leather pieces are hammered into place and capped. The cap is then secured with a steel pin, so the new leather handle is kept tightly in place. Next, a sander cuts deep grooves into the leather and smooths and tapers the handle for a better grip. Now, the handle is ready for painting. A brick of wax is loaded into the machine, and the leather rotates around it. The wax protects the handle against wear and moisture. Then, the grooves are colored with a black dye, which soaks easily into the leather. And the handle is complete. Each side of the cutting edge is sharpened by hand to exactly a 20-degree angle. Any thicker, and the knife will be dull. Any thinner, and the blade won't last. A skill that takes a master craftsman years to perfect. Finally, the blade is polished against a cotton wheel. This buffs the metal and removes any imperfections left on the blade. Once polished, the master craftsman takes each blade and slices it through a piece of paper. If the knife is too dull, the paper will crumple, but if it slices cleanly, it's ready for testing. First, a laser beam measures the angles of the cutting edge. If it's 1 degree off the 20-degree sweet spot, it goes back for resharpening. If the angle is accurate, the blade must pass the rope test. If it can't get through a piece of nylon rope in 2 slices, it doesn't make the cut. Then the knife is checked for imperfections. Even the smallest flaw means it's sent back for refinishing, or ends up opening boxes on the factory floor. Once the knife has passed inspection, it's boxed up and shipped out for active duty. The K-bar knife has served alongside generations of fighting men and women. Whether it was close-quarter combat or opening a can of rations, the K-bar was built to give a soldier the edge. Coming up on Battle Factory. This high-tech transport weighs 65 tons, and it's lighter than air. And a sniper's bullet that travels 3 long seconds to connect to its target. When these aluminum struts are joined together, they'll make up the shell of an airship that's never been seen in the sky before. Aeroscraft is the first of its kind, a 21st century take on the Zeppelin airship that has been part of flying tradition since the 1900s. Zeppelins of the day were originally designed as passenger ships and couldn't lift much cargo, and they were powered by highly flammable hydrogen gas. The Aeroscraft might look similar, but this military-funded prototype could revolutionize cargo and personnel transport. Airships of the future will be able to carry up to 250 tons of cargo and be able to take off and land vertically on any terrain with no need for a runway or ground personnel, making them the perfect transport system for bringing aid to ground zero in the aftermath of an earthquake or a hurricane. It took 10 years and $35 million to get the Dragon Dream prototype this far. But before it can go into full production, this experiment has to prove it can get off the ground. The Aeroscraft is made up of the helium buoyancy system, the aeroshell, the control center, and a rigid structure. The rigid structure is the skeleton of the Aeroscraft. It's made of lightweight aluminum and carbon fiber, strong enough to carry heavy loads and light enough for flight. Creating the trusses is like erecting a bridge. There are over 200 of them, ranging in length from 6 to 18 meters, and each truss has to be welded to the next by hand. It's taken 50 people 3 years to finally put together the form that creates the floor, the ceiling, and the cargo compartment. It's designed to be strong enough to support the propulsion system, the cockpit, and the helium containers. Helium gas is what makes the Aeroscraft lighter than air. In the past, the original airships would rise with the help of a lifting gas, hydrogen, and by dropping ballast, water. However, hydrogen is highly flammable, and an accidental spark could end in disaster, as it did with the infamous Hindenburg in 1937. Helium, which is not flammable, powers the Aeroscraft's groundbreaking variable buoyancy system. This enables it to move up and down like a submarine without taking on ballast. Simply adding compressed air from the surrounding atmosphere puts the helium under pressure, which reduces lift so the craft drops. Release the air, the helium expands, and the craft rises. So the first step in creating the buoyancy system is to make the large helium container. Made with lightweight plastic, filled with helium, and stored in the upper trusses of the ship's fuselage. It takes over 10,000 aluminum struts to make the outer shell. Wafers of honeycombed aluminum are sandwiched between each of the struts, and holes are punched out to make the aerodynamic frame even lighter. Once the shell is built, the next step is to cover it with a fabric skin made of mylar and carbon fiber. The skin is designed to deflect the heat of the sun away from the helium. Too much heat expands the gas and makes the ship harder to control. Once the exterior is complete, the glass cockpit, which includes seats and a touchscreen control panel, is suspended from the bottom of the ship. The Aeroscraft is steered by a rudder and powered by 3 engines which rotate on their bases for maximum maneuverability. The engines, wings, and the rudder are installed. After 5 years and $35 million, all the pieces of the Dragon Dream prototype are installed and ready for testing. Computer simulations can only predict so much. It all comes down to this moment. If this scale model gets off the ground, it will give the company the real-world results it needs to take production to the next level. A fleet of lighter-than-air aircraft that will be able to land anywhere on Earth and unload enough military force to protect a city, or enough humanitarian aid to feed one.
Five, 4, 3, 2, 1, 0. All engines running.
Liftoff. While the Aerocraft's maiden voyage only goes about 15 meters off the ground, the prototype's test flight was a success. Expectations are high. Now, the real work can begin. Coming up on Battle Factory, how to take down a target 2 kilometers away, and a plastic egg that's harmless until it hatches fire. In 48 hours, this harmless block of metal will be formed into the most accurate weapon on Earth. The AX-338 sniper rifle. Its predecessor, the AW-338, holds the record for the longest confirmed combat kill in recorded history. In Afghanistan in 2009, it was used to hit a target from 2.4 kilometers away. The AX-338 breaks down into 4 main parts: the magazine, the barrel, and the chassis and action. The chassis and action are the guts of the gun. Together they hold, feed, and fire the ammunition. The chassis is cut from a solid block of aluminum on a CNC machine, a computer-controlled cutting machine that ensures accuracy to the 10th of a millimeter. A coolant spray reduces friction and overheating. What makes this gun so accurate is that the chassis and the action are locked solid. There's never any movement between them, not even when the gun is being transported, and especially when the gun is fired. In long-range operations, even a microscopic shift means missing the target by several meters. Using the same process, the action is cut from a block of steel. The action and chassis are set aside in order to make the hinge. The hinge connects the butt of the gun to the chassis. It's made of 2 pieces of solid aluminum that join together perfectly. Once the hinge is locked in place, it doesn't budge. But when unlocked, it shortens the length of the rifle by 25 centimeters. In combat, the enemy is always on the lookout for the sniper whose longer rifle can give him away. But the ability to shorten the gun means the sniper now blends in with the other soldiers and avoids becoming a target himself. The mounting tube is an innovation developed to fasten night vision, lasers, and other accessories to the barrel. It starts as an aluminum cylinder. It is milled into an 8-sided shape with over 100 key slots drilled into its sides. The attachments hang off the slots. The mounting tube is free-floating, designed to fit over the barrel without touching it. That way, the weight of the attachments won't put the barrel off balance and affect the aim. The precision-designed barrel is 68.58 centimeters long and rifled with unique grooves on the inside wall that cause the bullet to spin and fly straight. When the bullet leaves this barrel, it'll be traveling at more than twice the speed of sound. In the record hit of 2009, the sniper's bullet took 3 seconds to travel 2.4 kilometers, or 20 city blocks, to connect to its target. For its final exam, the rifle is calibrated for 100 meters. Five shots are fired into the target. Every shot must land within this 3.5 centimeter diameter for the rifle to be deemed battle-ready. In a war zone, police standoff, or hostage-taking, the sniper is often the only solution to a bad situation. And if a target is caught in the crosshairs of an AX-338, from 20 city blocks away, he'll never know what hit him. Coming up on Battle Factory. Little plastic eggs that can burn a forest to the ground. These colorful plastic eggs may look harmless, but they're actually little time bombs that can set a forest floor ablaze in under a minute. Dragon eggs are mini missiles that are launched from a gas-powered cannon. 20 seconds later, the egg ignites to spark a strategic blaze from a safe distance. Firefighters use the combustible eggs to stop wildfires in their tracks by cutting off their fuel supply, fighting fire with fire. The Green Dragon launcher is made up of 3 parts: the chemical injection system, the launcher, and the eggs. The incendiary eggs are made up of 2 halves of a plastic sphere that's 3 centimeters in diameter. The egg is fueled with crystals of potassium permanganate, a chemical that on its own is harmless, stable, and non-combustible. Until you inject them with antifreeze or glycol, which, in 20 seconds, results in a volatile exothermic reaction that flares at over 2,200 degrees Celsius, causing enough firepower to set even wet wooded areas aflame. About 10,000 of these harmless-looking eggs are produced in a single shift. Enough firepower to burn 60,000 hectares. Agencies across North America and Australia will order over 2 million eggs in a year to control wildfires. The launcher contains 200 parts and takes almost 8 hours to assemble. With only 20 seconds between injection and ignition, the launcher's got to work perfectly or the whole system can backfire. The launch mechanism incorporates a 4-cycle system that moves the egg into the chamber, injects it with glycol, drops it into the barrel, then launches it on a blast of air. In Bosnia in 2012, Dragon eggs were fired from the turret of a tank to clear overgrown minefields almost 20 years after the conflict. On the firing range, the glycol reservoir is filled up, and up to 450 Dragon eggs are dropped into the hopper. The Green Dragon is armed and ready to deploy. Dragon eggs can be launched from a moving vehicle or dropped from the sky. The eggs are launched 40 times a minute and need to travel up to 60 meters in order to keep people out of the hot zone. The chemical reaction starts in the air, but doesn't fully ignite until the 20-second mark, once the innocent-looking egg hits the ground a safe distance from the cannon and the operators. This little plastic sphere may look like a child's toy, but when armed, it has the power to starve a wildfire or clear an overgrown battlefield.